The Grand Design was written by Stephen Hawking and Leonard Mlodinow. Stephen Hawking was one of the most famous scientists in the world. He worked mainly in physics and tried to answer big questions about the universe, like how it began and how it works. Leonard Mlodinow is also a physicist and writer who has helped explain complex science in a simple way. Together, they wrote this book to talk about how the universe works and to explore the idea that science, not a god, can explain why the universe exists. The book was published in 2010, and at that time, many people were still discussing whether science or religion could better explain the beginning of the universe. The authors wanted to show that science has now reached a point where it can give answers to some of the deepest questions people have asked for centuries. They didn't just talk about facts and numbers. They tried to explain ideas in a way that curious people could understand, even if they weren't scientists. Right from the beginning of the book, Hawking and Mlodinow ask a very big question. Why is there something instead of nothing? They say that in the past, people answered this question by saying that a god created the world. But now, with new discoveries in physics, there are other ways to answer it. The authors suggest that the laws of nature can explain the creation of the universe. They say that we don't need to believe in a god to understand how everything started. They begin by talking about how people in the past tried to understand the world. Ancient people often explained natural events with stories about gods and spirits. Later, philosophers in Greece and other places began to look for more logical explanations. Still, science as we know it didn't really start until people began to test ideas through experiments. The authors explain that modern science depends on observation and mathematics, and these are the tools we use to find out how nature works. One idea that comes up again and again in the book is something called model-dependent realism. Basically, they say that we can never really know what reality is like in a perfect way. Instead, we create models that help us understand what we see. If a model works well and helps us make correct predictions, then we can say that it gives us a good picture of reality. But we always have to remember that it's still just a model. An example they give is how light can be seen as both a wave and a particle. This is something from quantum physics. Depending on the experiment, light behaves like one or the other. Both models are useful, even though they seem different. The authors say that we should accept that there can be different ways to describe the same thing. What matters is whether the model helps us understand and predict what happens in the real world. The book also talks a lot about the history of science and how our understanding of the universe has changed over time. For example, people used to believe that the Earth was the center of the universe. Then, scientists like Copernicus and Galileo showed that the Earth goes around the sun. Later, Isaac Newton discovered the laws of gravity, which helped explain the motion of planets. These ideas were very powerful and gave people a much better understanding of how the universe works. But Newton's laws couldn't explain everything. In the 20th century, Albert Einstein came up with the theory of relativity, which showed that space and time are connected and can change depending on speed and gravity. Around the same time, scientists were also discovering strange things at the smallest scales. This became known as quantum mechanics. Quantum theory says that particles don't always have one fixed position or speed. Instead, they exist in a kind of cloud of possibilities until they are observed. This leads to one of the most surprising ideas in the Grand Design. The universe might not have just one history. The authors talk about something called the Feynman sum over histories. This idea says that instead of having one path, the universe could follow many possible paths at the same time. Only when we observe it do we see one result. This is very different from how we usually think, but in quantum physics, this is a serious idea. Another major topic in the book is the beginning of the universe. Hawking and Mlodinow explain that according to current scientific theories, the universe could have started without any cause. They say that because of the laws of physics, especially gravity, it's possible for the universe to come from nothing. This doesn't mean that nothing is a place. Instead, it means that the universe can appear as a result of natural laws without needing someone to create it. They compare this to bubbles forming in water. The bubbles appear naturally, and the universe could form in a similar way. They also talk about something called the multiverse. This is the idea that our universe might be just one of many. Each universe in the multiverse could have different laws of physics. In most of them, life wouldn't be possible. But in a few, like ours, the conditions are just right for life to exist. The authors say this might help explain why our universe seems so perfectly designed for life, because we live in the one where life can happen. Of course, this is still just a theory. There is no direct evidence for other universes yet, but the idea fits with some of the equations and models in modern physics. Hawking and Mlodinow suggest that the multiverse could be real, even if we can't see the other universes directly. Throughout the book, the authors return to the idea that science is now strong enough to answer the big questions that people used to ask religion. They don't say that religion is wrong, but they believe that science gives better explanations that can be tested and improved. In their view, asking what caused the universe is not the right question anymore. Instead, we should ask what laws made the universe possible, and how do those laws work? Hawking and Mlodinow don't try to push their ideas too strongly. They explain what the science says and why it makes sense. They also admit that some things are still unknown and that theories can change. But they believe that the direction science is going supports the idea that a creator is not necessary to explain the universe. One of the strongest points they make is about the power of scientific laws. The fact that we can describe how nature works with simple formulas is amazing. These laws, like gravity and quantum mechanics, apply everywhere and at all times. If the laws are strong enough to make the universe from nothing, then we don't need to look for something else to explain it. The book ends by saying that we are part of a universe that follows rules. These rules can be discovered, and we can understand them better and better over time. In this way, the authors are hopeful. Even though the universe is huge and often strange, it is also something we can study and make sense of. Science gives us the tools to do that. In the end, The Grand Design is a book that tries to answer old questions with new ideas. It combines the latest science with clear thinking. Even though some of the topics are complex, the authors explain them in a way that many people can follow. The book asks us to think deeply about where we come from and why we are here, but it also gives simple, science-based answers to those questions.